In this video, let us solve question number 34 of CBSE Class 10 Maths Sample Question Paper 2024. The question carries 5 marks and is taken from the chapter Surface Area and Volumes. There are two questions and you can solve any one of the following. The first among this is water is flowing at the rate of 15 km per hour through a pipe of diameter 14 centimeter into a cuboidal pond which is 50-meter long and 44-meter wide. At what time will the level of water in the pond rise by 21 centimeter? What should be the speed of water if the rise in water level is to be attained in 1 hour? What has been given here? A cylindrical pipe. Its diameter is given 14 centimeter. Diameter 14 centimeter. And water is flowing into the cuboidal pond. Its dimensions are this is a cuboidal pond. It's it is 50-meter long and 44-meter wide, and there is a rise in level of water by 21 centimeter. So now let us write the dimensions of cylindrical pipe. Diameter of the pipe is 14 centimeter. So radius is 7 centimeter. 14 by 2, that is 7. We have to convert it into meter. All the other units are in meter. All the units should be the same. So 100 centimeter is 1 meter. 7 centimeter. How much meter? 7 by 100 meter. We also know that water is flowing at the rate of 15 kilometer per hour. Here, from here to here, 15 kilometer per hour. Rate of flow is 15 kilometer per hour. We have to convert it into meter. It is given in kilometer. We have to convert it into meter. 15,000 meter. Now we can find the volume of the water in the pipe by using the formula pi r square h. Here pi is 22 by 7. Radius is 7 by 100 r square. So 7 by 100. This is a height of the cylinder. 15,000. We need not solve it. Just write it as meter cube. So now let us have the dimensions of the cubical part. Length of the cuboidal tank is 50 meter. Breadth of the cuboidal tank is 44 meter. Rise in water level, that is h. Height is 21 centimeter. Let us convert it into meter. 21 by 100 meter. Now let us find the volume of the water in cuboidal tank. We know volume of cuboidal structure is length into breadth into height. Now let us substitute the values. 50 into 44 into 21 by 100 meter cube. Time required to fill the pond by 21 centimeter. How we can find out it? Time is equal to volume of tank, that is cuboidal tank, divided by volume of pipe. in 1 hour. Okay. Now, volume of the tank. Let me write the things in blue color to avoid confusion. Volume of tank, we know it. We know that it is 50 into 44 into 21 by 100 divided by, let me write volume of water in pipe in purple color. What it is? Pi. Pi is 22 by 7. We have already find out it. 7 by 100 r square. 7 by 100 into h is 15,000. Now let us rearrange. 50 into 44 into 21 into 100. This 100 comes here into 100. 22 into 7 into 7 into 15,000. This 7, this 100, this 100 comes here. Or you could have cancelled here only. Okay, I forgotten. Nothing to worry. 7 into 100 into 100. Now let us cancel the possible things to make the problem easier. Here two zeros, here two zeros. 7 and 7 get cancels. 7 ones are, 7 threes are 21. 3 ones are, 3 fifties are, 50 ones are, 50 ones are. 50 and 50 get cancels. 22 ones are, 22 twos are. So time required is 2 hours. In 2 hours, the tank fills by 21 centimeter. Time required to fill that pond by 21 centimeter is 2 hours. We have the question that what should be the speed of water if the rise in water level is to be attained in 1 hour. We have seen that 21 centimeter of rise in water level is attained in 2 hours. Then the speed of water is 15 kilometer per hour. We know that in 1 hour water tank the speed of water is 15 kilometer per hour. But now we require 2 hours to fill the tank. Then the speed, how much is the speed? It should be attained in 1 hour. 15 into 2, that is 30 kilometer per hour. If water flows through the cylindrical part in 30 kilometer per hour, in 1 hour only the cuboidal tank fills up by 21 centimeter. The other question is, a tent is in the shape of cylinder like this, surmounted by conical top. The height and radius of the cylindrical part are 3 meter and 14 meter respectively. Cylindrical part height is what it is? 3 meter. Radius of the cylindrical part is 14 centimeter. And the total height, full length, is 13.5 meter. Find the area of the canvas required for making the tent, keeping provision for 26 meter square of canvas for stitching and wastage, and also find the cost of canvas to be purchased at the rate of rupees 500 per meter square. That means now we have to find the total surface area of the structure, and we have to add the wastage here. What is the wastage? 26 meter square for stitching and wastage. Okay, we have to find the area of the canvas and also cost of the canvas to be purchased at the rate of rupees 500 per meter square. Now we have the cylinder and we are given all the measures. What are they? Radius of the cylinder is 14 meter. Radius is 14 meter. I have written here only, no need to worry. Height of the cylinder is 3 meter. Total height of the cylinder is 13.5 meter. That means here we have a conical part. We have to find the height of the conical part. How can we get it? Total height minus height of the cylinder. Total height is 13.5 minus height of the cylinder is 3 meter. So it is 10.5 meter. Since we are needed to find the total surface area of the tent, which is equal to CSA of cylinder plus CSA of cone, and the CSA of cone is equal to pi RL. Now let us find the slant height L of the cone. Slant height of the cone L is equal to, this is equal to what? Square root of h square plus r square. By using Pythagoras theorem, you can do it, isn't it? Here 90° h square plus r square. Height is 10.5 square plus radius is 14 square. That is equal to 110.25 plus 196. That is equal to square root of 306.25. That is equal, square root of 306.25 is 17.5. So slant height of the cone is 17.5 meter. Now let us find the area of the canvas required for making the tent, keeping a provision of 26 meter square of canvas for stitching and wastage. For that, first, now let us find the total surface area of this structure, which is equal to CSA of cylinder plus CSA of cone. So, area of the canvas required is equal to curved surface area of the cylinder plus curved surface area of the cone. Now, we know that curved surface area of the cylinder is 2 pi r h. Curved surface area of the cone is pi r l. Radius is common for both cylinder and cone, which is equal to 14 centimeter. Now we can take pi r common to make the problem easier. 2 into h plus l. Pi is 22 by 7, radius is 14. 2 into h is 3 plus 17.5. Here 7 ones are, 7 twos are, that is equal to 44. Here 6 plus 17.5. What it is? 23.5. 23.5. 44 into 23.5. So now we can write area of the canvas required is 23.5 into 44. That is equal to, which is equal to 1034. Now let us write the unit, meter square. We know that there is wastage and stitch allowance is 26 meter square. So total area of the canvas required is 1034 plus 26. That is equal to 1060 meter square. So now we know the area of the canvas required is 1060 meter square. We have to find the cost of the canvas to be purchased at the rate of rupees 500 per meter square. For 1 meter square, rupees 500. For 1060 meter square, how much we have to find out. So 1060 into 500, that is equal to 5 lakh 30,000 rupees. So cost of canvas is rupees 5 lakh 30,000.